Good afternoon. It's really an immense pleasure for me and an honor to be here. And I want to congratulate Ricardo Salinas and Andres Romer for putting together this immense show. It gets better every year, and it's so much better than any other show. I think this is the greatest show on earth. So I think we could give them an ovation. Thank you. This was the easy part. The hard part is to tell you the entire history of mathematics in 10 minutes. So I hope I can do it. What is mathematics? We don't know. You met a mathematician this morning, Arthur Benjamin. So all mathematicians, and I've met all of them, they're all very peculiar people. They're very different from the rest of us. Here's one of the first. This is the first pure mathematician. You can see he's pure. He's Pythagoras, who gave us the Pythagorean theorem, Greek, of course. I don't know. The Greeks were so great. They invented pure mathematics, but now they don't really help the world economy very much. So there are a few of them here. Plato's Academy in Athens. They were really great philosophers and mathematicians. And philosophy and mathematics have been linked together ever since. Mathematics really started in Egypt with people pulling ropes on the Nile River, trying to demarcate fields after the Nile River has receded to know who owns what. But the Greeks didn't like that. They don't like private property or any property. So they really started tying it together with philosophy and talk about things that are really just abstract, and we call them Platonic today. These are the Platonic solids. They are supposed to be mystical. And later on, that mysticism about them remained through history, at least until the 1500s. Here's Archimedes, the first crazy mathematician. He discovered something very interesting about when he put his body in water and how much it weighed. So he jumped out of the bathtub and ran naked through Syracuse. Very normal behavior for a mathematician. Here's another mathematician, Eratosthenes, made one of the greatest experiments for the time. He measured the size of the Earth, and he got it to very great accuracy, as 25,000 miles or 40,000 kilometers around. He was able to do that using the rays of the sun and the shadow of the sun at different places. And of course, in India, mathematics developed on its own. The numerals that we use today come from India and through Arabia. Here's an Arab mathematician who did some important work. Chinese mathematics developed at the same time. There were not many connections, and the magic square, which is something that I find very interesting, all the numbers add certain ways, comes from China. Then we go to the Middle Ages and later. Leonardo da Vinci worked with mathematicians. He had mathematician friends, and this is an attempt to square the circle, which is one of the three classical problems of antiquity. One is squaring the circle, and you can see the man there is once in a circle and the other time inside the square. So you want to create a circle with a square with the same area as a circle, which we know today is an impossible problem. There are two other impossible problems. Here are some magic squares from Europe in a Dürer. The magic squares continue to fascinate us. This is Leonardo's friend Luca Pacioli, who did work on art, using mathematics in art. And then, of course, things became very complicated in Europe because mathematics and science coming together told people that the Earth is not the center of the universe. And if it's not the center of the universe, that caused lots of religious problems. And Galileo, of course, had some problems. This is John Napier invented logarithms, and he kept a spider in a box. He also had a black crow. So he liked this to play with animals and play tricks on people. This is Johann Kepler, of course, a great mathematician who found the orbits of the planets in the solar system. And what's interesting here if you look at this picture, these are the Platonic solids that go back to Plato, and he tried to explain the entire solar system with these Greek ideas of pure mathematics. Of course, it didn't work. Galileo's work got him in trouble, of course, with the Inquisition as well. When he went home to Arcetri, where he was on house arrest, he developed some pure mathematics, which not many people know, and that is he developed some ideas of infinity. And he was able to show that the order of infinity of all the numbers and all the square numbers is the same. Here's René Descartes, one of my favorite mathematicians, and a very peculiar man. He did great mathematics, but he was also a swordsman who liked to fight everywhere he went. Usually it was for beautiful women. He'd fight duels for their honor. He was also a mystic, and some of his notation comes right from astrology and the black arts and Rosicrucianism. Here he is in the Battle of Prague and tutoring the Queen of Sweden. This is the stupidest experiment in history. This is inspired by Descartes. Descartes suggested to Mersenne, he's the priest on the left, that he prove the rotation of the Earth by firing a cannon parallel to the horizon. But Mersenne didn't understand him. He fired it straight up. And the first the first cannonball disappeared. And after they fired the second one, they understood that something could happen that's not very pleasant, so they ran away, left this experiment. This is the dumbest experiment in all of history. Here's Descartes dueling for the honor of a beautiful woman, which he did quite often. He also taught himself Dutch because at some point he realized he was a mathematician by asking a Dutchman to translate for him a puzzle that was pasted on a wall somewhere in Breda, in Holland. And the man said, "Oh, you're French, you wouldn't understand that." Of course, Descartes said, "Yes, I'll give the solution when I find it." And the next day, he gave him the solution. Then he taught himself Dutch because he never wanted another encounter like this one. So he was once on the high seas trying to take a boat to visit some islands, and the crew of the boat were talking about throwing him and his valet, he always traveled everywhere with a valet, overboard and grabbing their money. But Descartes by then had understood every word of Dutch. He pulled out his sword, which he always had with him, and chased them on deck, swearing at them in their own language. They, according to his first biographer, he ran away. They ran away from him on board and took him to where he wanted to go very peacefully. This is a Cartesian coordinate system, and I wanted to show you here that it appears everywhere. Most things we do use this Cartesian coordinates, and one of the most important uses that we make of it today is through the GPS system. Now, everywhere I speak about mathematics or about any other topic related to it, eventually somebody asks me, "Can you tell us about the neutrinos? These neutrinos that go faster than light." This just happened about 6 weeks ago in an experiment in Italy and Switzerland. And the GPS system was what's used, the Cartesian coordinates through the GPS system was what's used to measure the speed of these neutrinos going underground from Switzerland to Italy. And a lot of people are asking questions, well, maybe they made a mistake. Now, the GPS doesn't make mistakes. It measures things to immense accuracy. A physicist from MIT asked about the team doing the experiment, said, no, there are no errors there. You have to understand, you're dealing with Swiss, Germans, and clocks. It doesn't get any more accurate than that. So this is a story about the neutrinos. We still don't know. They appear to be going faster than light, but the jury is still out, so to speak. Every physicist on the face of the earth is trying to prove them wrong, because Einstein, of course, told us that it's very difficult to go faster than light. It's not forbidden under the theory of relativity, by the way. If you start going faster than light, you can do that, but you must stay faster than light. You can't slow down to the speed of light. So relativity is not really disproven by it, but Einstein is probably rolling in his grave now. So here's Fermat with Fermat's last theorem, which was my first book. These two guys, Leibniz and Newton, they invented the calculus and thought about it through the century. Here's Gauss and Euler. Euler was a very good mathematician, Gauss was a child prodigy. When he was very young, 10 years old, the teacher told the students, stay in class today, and I want you to add up all the numbers from 1 to 100. And a minute later, this guy on the right, he's out the door. And the teacher runs after him, yells at him, they're Germans. And he says, this is impossible, you couldn't have done this. And he says, yes, I did. And this is how I did it. So what Gauss did, one of the greatest mathematicians of all time, he realized if he put all the numbers in an array, 0, 1, up to 100, and under them the numbers in the opposite order, and then added all of these together. It's a sum of 100, and there are 101 of them, so all he had to do is 100 times 101 divided by 2, and it gives you the answer. It took him just a few seconds. This is what mathematicians do. Napoleon loved mathematicians. He had several mathematicians go with him to Egypt just to chase the Egyptians. This is Laplace, who was one of them there in Egypt. This is Galois. He's a guy who died at 20 in a duel because nobody understood his mathematics. His mathematics was so ahead of his time that when he was asked a question in his examination about logarithms, he got so upset, he took the eraser and threw it at the professor. That was the end of it. Then he had a duel for a woman, of course, and he died at the age of 20. So, yep, this is Cantor went crazy trying to understand infinity, and the two guys, the one on the left was his friend, the guy on the right tormented him throughout his life. And this is Ramanujan in my last story. Ramanujan was a famous Indian mathematician, also led a very tragic life. He was ill with TB, and Hardy, a British mathematician, brought him to England. He was already sick, and he was brilliant. He wrote all these theorems and more theorems, and he was lying in bed dying. Hardy comes to him, and he doesn't know what to say to cheer him up, and he says, you know, I came here in a cab, and the taxi had a very boring number, 1729. And Ramanujan, half dead, jumps up in bed and says, no, Hardy, it's a very interesting number. It's the smallest number expressible as a sum of 2 cubes in 2 different ways. And I'll leave you to try to figure out these numbers, unless Arthur Benjamin is here, and he probably did it a few minutes ago. Thank you very much.